So we've got in collected, these three were due today. And so this is now view only because it starts grading it. See? That right there. So you got to get them in, and we can't be working 2 steps behind because we got more worksheets to do. Thursday, the calculator practice worksheet is due, and the manatee worksheet. Now, if we have time today, we can work on some of that during class. You can ask questions. We can work on some of that at the end of class today, maybe the last half hour. So, which we should have time for that. So you got to keep up. Keep looking at Shobi to make sure when things are due, and keep up with it. Go to the Learning Center. If you're not, or watch Peggy, or get some other help, you can come to my office for help. That's fine. I'd be glad to help you in my office, but I can't really help you much with Excel in my office because I only have one computer. Okay. It'd be better at the Learning Center. They know how to make those graphs, and they'll help you. And you can pull up Excel on those computers. So if anybody needs to turn in any of these worksheets today as paper copies, by the end of the class, you can do that. And if you're not able to see it in Shobi, then I'm not able to see it. So turn it in on paper, I guess. Make sure. If you're not sure, I guess it's better to turn it in on paper. And you could email it to me in D2L. I don't know why I could read Summer's emails in D2L, but no. Okay. So weird. But we'll get this straight. You should be able to show me. So what do we got? Here's our schedule. We have a test in 1 week. Test 1. We have a test in 1 week. So we're going to finish chapter 3 today, and you can work on these. These 2 worksheets are due on Thursday, and so is D2L quiz 3. And you get 2 attempts at this quiz, and you get to see what you missed between them. So D2L quiz 3 is due Thursday, but it's not showing up yet because it's what? It doesn't open until 1:30. Right. So okay. So we have a test in a week on. It's our first test, and I don't like to. This chapters 1, 2, and 3 are the easy material in this class, so we don't want to delay that test and spend more time on chapter 1, 2, and 3. This is actually the easy stuff. You're using your calculator to find statistics. You're drawing graphs. So that's it. It gets a little more complicated later. So, all right. Let me pause this and I'll take roll. Okay, so Shobi, this is what's due. Does everybody understand that it's your responsibility to get your work displayed in Shobi? If you can't get it displayed, you can send it to me, email D2L, or if it's a class day, you can actually give it to me in class. But we're going to try to, maybe after class, figure out why it's not doing why it's not working. Okay? Maybe we need to convert your picture to a PDF. I don't know. All right. Okay. Okay, here's where we were we were on measures of variation. We have, this is the chapter 3 notes, right after the space shuttle example. We were on coefficient of variation. I don't know, maybe I have a Nearpod. Oh, we just work it. Okay. So here's coefficient of variation. Now, we just covered standard deviation. Standard deviation, you're going to use your calculator to find it. And it's in the same units as the mean. And if we want variance, we're just going to square the standard deviation, but make sure you keep 4 decimal places. Otherwise, you'll be getting the wrong answer. It won't be the right number. It'll be off. It could be off, like for this example, it's off by almost 5. And my stat lab is going to count it wrong, and I'll take off a little bit, but not much. So that's standard deviation, but we can only use standard deviation to compare a data set if the means are about in the same place and if they're on the same scale. So I do have a Nearpod on this. So let's open up this Nearpod. I do have a nice Nearpod. Okay, my library, 1530, and I have, I'm going to have to skip to where we are. Oh no. I'm going to cancel that one. Oh, 1530. I know I have a measures of variation one. Intro to chapter 3. Where's the measure? Where did that one go? I have too many, I think. Probability, chapter 2. Oh, here, weighted mean. Oh, measures of variation. Do that one. Okay, KOCHT, go to nearpod.com and type in KOCHT. Because it has some activities there. Bring a marker. KOCHT. Okay. Okay, so we're recording this and every little sound picks up. So see those microphones are picking up all your voices. Okay, so that was the weighted mean example. We already went through that. So measures of this is just, I'm just picking this up. These are some symbols. Small s is the sample standard deviation symbol, and that's the formula. small sigma is, the Greek letter sigma is the population standard deviation, and it uses population mean and population size. We've got sample mean here, sample size in the formula. But you don't need to use this formula, and if you click in MyStatLab to help me solve this or view an example for standard deviations, it might take you through this formula and you go through 3 pages of work. But no, you're just supposed to put your data in a list in the calculator. Oh, I'm skipping this stuff. Okay, so we've got variance is just standard deviation squared. So, but we have to keep 4 decimal places. So these are symbols. You need to know these symbols, S squared and sigma squared. So we did this example, and the range rule of thumb for identifying significant values is that most data is at bell shape, so 95% lie within 2 standard deviations of the mean. So the minimum significant value and maximum is written like that. And so we found the lowest duration time was unusual on our papers, and finding measures of center, calculator worksheet, no I don't. Okay, so now I wanted to show you this. So on our paper, this is as far as we got. We got that the minimum, the lowest duration time, 0 hours, was unusual because 0 was less than 5.5. So that's an unusual duration time. Now we're on coefficient of variation, and this is how we compare data sets. So if you want to compare the variability in a loaf of bread to the variability in price of the price of a sedan, those are in totally different scales. You can't use standard deviation because the means are not approximately equal, for one thing. So in order to use standard deviation, we can only do that when the means are approximately the same. And when it's very different data, we can't do it. So we're going to use what's called the coefficient of variation. So this is the coefficient of variation. It's the standard deviation relative to the mean. So it's the coefficient of variation, and we'll write this down on our paper, is the standard deviation divided by the mean, and we're going to multiply it by 100% to write it as a percentage. And the lower the coefficient of variation, the less variability in the data. So the coefficient of variation is the standard deviation relative to the mean. That's why we subtract. And these are in the same units, so coefficient of variation doesn't have units. So let me write this. So you can see that. We're going to bring that back up in a minute. So coefficient of variation, or CV, is standard deviation divided by the mean. And then we'll write it in percent, so we're going to multiply that by 100%. That's what it is. If we write it in, if we have sample data, we'll use sample symbols. If it's sample data, then we'll have the CV is S divided by X bar. Times 100%. If we have population data, we'll write it with population symbols. You need to know these symbols too. It's going to be sigma divided by mu times 100%. So that's what coefficient of variation is. And standard deviation and mean are in the same units, so the units cancel out. So this is the unit list. So it doesn't depend on the units, feet or inches or pounds. Doesn't depend on that. So this is the best way to compare two totally different data sets. So we have an example in my little slideshow has the same example here. So we'll go back to this. You can see that there. So we've got two sets of data. We've got the Atlanta Braves Major League Baseball team. We've got a random sample of 8 players, and we got their heights and their weights. So we're going to go into our calculator and put our heights in list 1 and our weights in list 2. Okay, so you got to bring the calculator up. So you should follow along with your calculator. There's one on your keyboard, on your computer if you want to use that one. And since we're in a room with computers, I do let you use this calculator on your desktop during tests if you want to use that one. Okay, so how do we put data in lists? Do you guys remember? We press Stat, Error, and then we hit Enter for edit. We're going to clear out this list. We press Clear down arrow. And then we put in the data, 71, 75, 74, 72, 73, 73, 76, and 72. And that was 8 values, and I'll double check I typed them in right. And then go in and put the weights in list 2, 220, 210, 220, 185, 175, 170, 210, and 175. Okay, we got it. And does everybody have that in their calculators? You all know how to put it in your calculator? Everybody that's in this room probably knows to put it in your calculator. Okay. How to put it in your calculator. Very important to do this, because if you click Help Me Solve This on this, or view an example, it might take you to do this by hand. No, you're not going to do that. Oh my gosh, it'd be like 5 pages of work by hand. Who wants to do that? Okay, so we got it in our calculator. Second, quit. So this is my home screen. It's cleared out. So I press Stat, Calc, 1 variable statistics. Enter. And I'm just going to do list 1 first. Well, I'm going to find CV for height. And CV for height is S over X bar times 100%. So I have my heights in list 1. So I just want to do 1 variable stats. And if it's in list 1, I can just hit Enter. So this is not a frequency list. So you frequency list, you guys that have the Stat Wizard, leave that blank. Frequency list should be blank. Does your frequency list have something in it? Good. Okay. Just hit Enter. This is we're just doing list 1, a plain list of data, list 1. Because these could have different number of data in them. So, and you don't want, it's not a frequency distribution. Okay. So, there's our S, it's given to us under SX. So we're going to keep 4 decimal places. So we're going to write that down as 1.669, whoops, 1.6690. And then we're going to divide by x bar, and x bar only went to 2 places. So but if it went to 4, you keep them all. 73.25, right? So again, I'm going to write down this keep 4 decimal places until the end. And you keep 4 on this also, but it only went to 2. So you keep at least 4 unless it stops before then, okay? Because otherwise you're going to get the wrong answers, and StatLab's going to keep telling you it's wrong. So the easiest way is just to type this in, 1.699 divided by 73.25, and then I'm going to multiply by 100 to change it to percent. So times 100%, and we get 2.3% to one place. Okay? Is that what you got? Did you get 2.3%? Did you get something different? Oh, you didn't type in 1.669, you typed in 1.66. So, yeah. It's, statistics is a lot of detailed typing numbers in, so you have to double check. Double check that you didn't mess up typing those in. So that's 2.3%. Now we're going to find CV for weight.
Shouldn't it be 1.669 divided by 73.25?
Oh, wait a minute. I typed it in wrong. Ha! Okay, let me recall my last entry. See? I thought, but she typed it in wrong too, right? Oh no. 1.6, oh, those 6s and 9s look awful lot alike. Okay, we got it right now? Oh yes. But it's still times 100 then. Okay. Okay, 2.3%. Does that match your number now? Okay, it should match. Does that match everybody now? Good, good. I typed it in wrong. The 6 and the 9. Gotta be so careful. Okay, so the other thing you can do is when you do one variable statistic, your calculator actually keeps those numbers stored, and it stores them. So the easiest thing is to type it in, but you can see I made a mistake doing that. So this is extra, if you're good at technology and want to do this, you can use your calculator. You can go to, I'll write down the steps, to go to variables on your calculator. I'm going to go to variables, and then I go to number 5, statistics. And your calculator, okay, so I can either arrow down to 5 and hit enter or press 5. And here your calculator will keep the last n you use, the last x bar, the last sample standard deviations, number 3. So what I want to do is choose number 3 first. I want to do this formula in the calculator. It's going to look just like this. Sx divided by x bar. So I'm going to choose number 3. X bar, oh no, not number 3. Yes, number 3 is Sx. And then I'm going to press the divided by, and then I'm going to go back to variables and 5 statistics So I'll do variable 5, and I'm going to choose number 2. And that is x bar. So the calculator will show Sx divided by x bar. And this is just so if you're good at technology and want to do it this way, you choose number 3 divided by variable number 5, number 2 there, x bar, and enter, and then you multiply by 100. So we get, that's the exact answer, because the calculator kept all the decimal places. So if you like that, that's how I did it. Your calculator keeps those numbers in there, so you wouldn't even have to write down the 4 and then enter it. Whoops. Okay, now we're going to do CV. For weight, it's going to be S over x bar, but we're going to do one variable stats. We have our weights in list 2, so I'm going to choose second 2 for list 2. You have to, if you're using the stat wizard, you're going to change list 1 to list 2. So, stat, calc, one variable statistics, and then instead of hitting enter, because that would be list 1, we're going to press second 2 for list 2. Okay, and then hit enter. And then you can write down S to 4 places, would be 21.4539. I rounded on the last one. And X bar just goes to 3 places, 195.625 times 100%. Or you can, this calculator is a word processor. You can press second enter to recall your last entry. Second enter. That's not the entry I wanted. Hit second enter again. That's the answer times 100. Second enter. I wanted this one. Sx divided by x bar. I did second enter 3 times to recall my third to the last entry. Now that I did another one variable statistics with this data, it's going to actually divide when I've got the formula up here. It's going to take the standard deviation and divide it by the mean. So if you like this trick, you can do that. And then I'm going to multiply by 100. And you get, to 1 decimal place, you're going to get 11%. Now, if you want, you can type in the 21.4539 divided by 195.625. So, times 100. If you don't like technology, then maybe you want to do it that way. You get, it's only off in the 5th through 8th decimal place. It's only different. So it'll work to keep 4 decimal places. You know, if you spread them to 1, you're not going to get the right answer. It's kind of wrong. So whichever way you want to do it, you got that shortcut way. If you're good at technology, you can understand the calculator. And you've got writing it down to 4 decimal places. Which way do you guys like? Or are you going to try it? Okay. Any questions about that? So that's coefficient of variation. So we're going to go back and ask you a question about, in the Nearpod, So get back into Nearpod. Okay, oh, wait a minute, we didn't answer the question here. So, based on the sample data, okay, so we got our coefficient of variations. Answer this on the side. Based on the sample data, there's less variation in what? The height or the weight? Less variation. So which one is it? Right, because it's a lower coefficient of variation. And there's no units in this because the units this was height, was in inches. They canceled out. The units canceled out. This was in pounds and that canceled out. There's less variation in height because the coefficient of variation was less. Now I'm going to ask you a question, and we're going to do a poll and see. You can do it. We're going to do an anonymous poll. So, with this data, if we know that the mean price of bread is $2.19 and the standard deviation is 30 cents, then you just take 0.3 divided by 2.19 and multiply by 100 and you get 13.7%. That's how they got the coefficient of variation. And CD is the symbol I want you to use for that. Okay, and then to find this CD, they just took the standard deviation of 2,000 and divided by 17,900 and multiplied by 100. They got 11.2%. So which data set here has less variability? Is there less variability? Don't say it out loud or you're going to get a survey. It's a poll right now. Look at the numbers. Think of your answer. Which one has less variability? And we're going to see how you did, if you got this concept. There. Hide student names. Ah, that's what we need to do. I just hid your name. So you should have a poll that you can answer. Was it the price of bread or was it the price of the sedan? And I should have written down the numbers, so which we may have to look back at the slide to see the numbers again. So most people are choosing B. The sedan had less variability. So I can share it. And you guys can all see the percentages. Most people in the class thought that it was the sedan that had less variability. So about 3/4 of you thought that, and there's one person maybe that didn't answer. So, which one was it? I have to look back at the previous slide because the sedan had a lower percentage. So the majority had it. The sedan, a lower percent for the coefficient of variation means less variability. So it's the sedan. Now you can answer that poll again. Never mind. We're not going to answer it again. Okay? All right. Now we're on measures of location. And then after we finish, we should finish these notes today, and then we're going to spend the rest of the time working on the worksheets that are due next time, or Math Lab, or if you've already got the worksheets done, we'll work on Math Lab. So these are percentiles. These are measures of location. So that's what goes in your first blank, location. There's 99 percentiles. And they're denoted P1 through P99, and they divide a data set, only if it has more than 100 values in it, into groups with about 1% in each group. So those are the percentiles. We used to make you try to find the percentiles, but now we just want you to be able to interpret it. So here's an example. It's on your paper. it says if an infant child is in the 78th percentile for their weight and their gender, that means that the infant's weight is greater than 78% of all infants the same weight and gender and same age. Same age and gender. But it's not 78% of some ideal weight. We could also say the infant's weight is less than how many percent of all infants. We can take 100% minus 78%, and that's 22%. So that was the answer. Back to the slideshow. That's the answer in the slideshow, less than 22%. And they're talking about of an infant in the same, it is less than 22%. Of all infants the same gender and the same age. So that's what you need to be able to understand is interpreting percentiles. Now quartiles, this is on your paper. Quartiles divide a data set into 4 equal groups. So you put a 4 in that first spot, right here. I'm not showing you my paper because this is it. And 25% of the data is in each group. And then we have the 5-number summary on your paper. And this has got the 5-number summary, except it doesn't have, the minimum and the maximum have to be here. So you see on your paper, you've got the minimum. The 5-number summary is the minimum, the first quartile denoted as Q subscript 1. The second quartile is Q subscript 2, and that is also the median. The second quartile. And the third quartile is denoted as Q3. And the maximum is just the maximum. So this is the 5-number summary. And if you're asked for the 5-number summary for a data set, you just list them in order with commas between them. So you'll put the minimum value, comma, the first quartile, comma, the median, comma, third quartile, comma, the maximum. And if we've got 5 numbers like that, we know that statisticians know that's the 5-number summary. So, and our calculator will give that to us. You're going to see when we do this example. And so Q2 is also the median. Q2 separates the bottom 50% of sorted values, data values, from the top 50%. So that's the 5-number summary. And then the interquartile range is abbreviated, and that's the symbol for it, IQR, is Q3 minus Q1, the third quartile minus the first quartile. And then we've talked about outliers, and this definition's on your paper. Outliers are values that lie very far away from the vast majority of other values in the data set, but we can test for outliers. This is how we test for them. Well, first, talking about box plots. Oh, okay, let's show you the testing. I guess the slides are out of order. I've got it here. Here's the definition of outliers. And we call this the lower fence. Is Q1 minus 1.5 times the IQR. And the upper fence is any value larger than Q3 plus 1.5 times the IQR. So we can actually test, this is a formula to actually, instead of just saying it's very far away, how far is very far away? Well, if we have a measurement for it, we take the first quartile, we find the 5-number summary and take the first quartile and find out and subtract 1.5 times the IQR. Any value smaller than that would be any data value smaller than that would be considered an outlier. Any data value larger than Q3 plus 1.5 times the IQR. All right, and then we do a box and whisker plot. We use the 5-number summary to make this plot. This is the minimum. This is Q1, the median, and we'll make a box plot, Q3, and the maximum. And this is like how the calculator, it looks on the calculator, but you will want a scale under your box plot if I have you draw one. So that's a box plot. And we're just going to be drawing regular box plots. A modified one means that if we have an outlier data value, we're going to put a different symbol for it, like an asterisk or a box there, and then the next largest data value will show up here. That's the outlier, and so this is the next largest data value. And that's a modified box and whisker plot or box plot. We call them, for short, we call it a box plot. But this is the box, and these are the whiskers. That's where it got its name. Okay? Got that? And we're going to look back at this. So here's a box plot, but I don't want you to draw it like this. I want an actual scale, because you'll be tempted to draw it like symmetrical, even if it's not. You want to have a scale, 10, 20, 30, 40, 50, to make sure you're drawing these somewhat accurately. That's a box plot, and we use, like I said, the minimum, Q1, median, the 5-number summary to make a box plot. And this is some more examples. This is a bell-shaped distribution where the box is centered. This is, most of the data here is on the left, because 25% of the data is between the minimum and Q1, 25% between Q1 and the median, 25% between the median and Q3, and then 25% here. So most of the data is on the left, so the tail is on the right, so it's skewed right. The box plot will look like this for a skewed right distribution. Okay, so that, I need to move that, it got in the wrong place. That was the, how to find the lower fence and upper fence. A modified box plot example. Okay, and now we're on the example of the next page. Okay, so have any of you guys been to Cedar Point? It's up in Ohio. I have, but I didn't ride on some of these. I chickened out. But anyway, this is known as the roller coaster capital of the world, and listed below are the speeds of their roller coasters. And so we're going to find the 5-number summary, and we're going to use the calculator. So we're going to put this stuff in list 1. So we'll go back into the calculator, clear it out, clear, stat, edit, clear these, clear those. Okay, and then we type in 40, 40, 48, 67, 60, 40, 72, 60, 70, 65, 93, 43, 120, 57, 72, 6, and 25. Okay. So, let's make sure I typed it in right. For one thing, how many data values were there? 17. Okay. 52, 43, 93. You type one data value in wrong and the whole thing's going to be wrong. So you do have to double check. It looks like I got it in there right. Second, quit. So I do one variable statistics. So stat, calc, one variable stats. If you use list one, you just press enter. And then you're gonna, it says n equals 17 for one thing. We don't need this information for the 5-number summary. We arrow down as far as we can go, and the calculator gives us the 5-number summary. It's right there. It's not too hard to find it by hand, but you may as well just use the calculator. So here's the 5-number summary. The minimum is 6. Q1 is 40. The median is 60. Q3 is 71, and the max is 120. And for StatLab, it'll have blanks with commas between them. You will just put these numbers in. You don't label them. You put them in order. Okay? And, you know, we could find the median by hand by sorting this data and finding the middle data value. And then you take the middle of the left half of the data value and find Q1 in the middle of the right half. But I doubt anybody's really going to do that by hand since the calculator gives it to you. So if you want to see that, I show it to you after class. I'll do that. All right, and we're going to construct a box and whisker plot. So we don't want to just draw a symmetrical box and say that's it. We're going to draw a scale first. We're going to have a title, so I'm going to call this roller coaster speeds. And I'm going to make a straight line. You see that? And make a scale. So if I start at 0 and go by, let's see, I'm trying to go by 30, 60, 90, 120, and then this would be 10, 20, 40, 50, and I don't know, it's pretty close. Okay, close enough. So that's our scale, and then we need a title. This is speed. And what are the units? In miles per hour, mph. So the minimum value is 6, so that's, we make a little whisker right there. The maximum value is 120, so we make a little whisker here, and I don't know, if I have my straight edge, this, I can use this. It's probably easier to use a straight edge. You have to connect this, and it's okay if you connect it all the way across. It's supposed to be horizontal. Alright, that's the minimum and max, and that's the whisker part. And then you're going to make the box. So go to Q1, that's at 40, and make a bigger vertical line. And then go to 71, and then you connect that box. That's your box. And then go to the median is at 60, you're going to make a vertical line. And if you want, you can label these 6, 40, 60, 71, 120. You can label them like that. But that's your box plot. So you make a box plot. Okay. Then we're going to find the IQR. The IQR is Q3 minus Q1. So that's 71 minus 40 is 31 miles per hour. So we got it labeled as IQR. What if it asked for the range? This one didn't, but what if it asked for range? Range is max minus min. The 120 minus the 6, 114. Range is 114. Okay, let's see if we have any outlier data values. So, we're going to find the lower fence. Q1 is 40, and we're going to subtract 1.5 times the IQR, which is 31. Now you don't want to take 40 minus 1.5 and get 38.5 and then multiply it by 31. That would be a huge number. You have to do the right order of operations. You would multiply before you subtract, or if you put it in your calculator, it's going to do the right order of operations. So you're going to put in 40 minus 1.5 times 31. And you get negative 6.5. This happens a lot. We get a lower fence that's in the negative numbers. If we have no negative data, we'll have no outliers on the low end. It just means that we don't have outliers on the low end. This is not a data value, negative 6.5. It's the lower fence. It means any data below negative 6.5 would be an outlier. Well, we just have all positive speeds, even though some of these roller coasters, as I've been there before, they go backwards. Forwards and then backwards. So they didn't put the negative speeds down. So. All right, so there are no outliers on the low end. Then the last one is take Q3. Make sure you don't use 40. You got to use Q3, which is 71, and add 1.5 times 31. So we can type in 71 plus 1.5 times 31. And that's 117.5. Any data values above 117.5 would be considered outliers. So look at our data. Do we have any data above 117.5 miles per hour? Yes, one data value, 120, is an outlier. That's the Top Thrill Dragster. It went straight up and then straight down, and I didn't do that one. It went straight up like a huge, I mean not just little, it went really high up, really much, I don't know. And the problem with it is that you can't get off in the middle of the ride. That's why I didn't get off. So, that goes 120 miles per hour. So 120 would be an outlier. But I won't ask you to draw the modified box plot. I just want you to draw this box plot. But there's a problem similar to this on the test where you have to go through all this. There's problems like this on the worksheet. So we're going to take a break and work on the worksheets. You can ask help. You've got that manatee worksheet with a lot of pages. You probably want to work on that. You've got the calculator worksheet. I'll think I have a copy of it here. You're supposed to label the data values with the proper symbol. So if it's population data, you're going to label it with the population symbols. Oh, yeah. And, all right, let's see if I can find, thought I had it. So we finished the chapter 3 notes. So here, it looks different ways depending on, it has a girl walking a dog or it has this dog on it. It's the same sheet. So the Calculator 3 practice is just one page. You need to use, label all answers with correct notation, the right symbol if it has a symbol. So I wrote down the symbols for you. So since this is a sample, this will be X bar. This will be S, and this will be S squared. When you find S squared, you need to take S to 4 decimal places at least and square it. And then you're going to round to 2 decimal places. So you'll round this to 2 places, but you'll keep 4 to square it and get S squared, or the variance. And this second one is the population and its frequency data. So you find the midpoints. So these are the hints for this. I don't know if you can see that, if I make it too small. These are the hints for the second problem. I can show this to you again. This is all the students in the section were included. This is the population. So you're going to use mu and v, sigma for standard deviation, sigma squared variance, which keeps 4 decimal places on sigma when you square it. So, yes. What function did I do?
To get the list of like the human index.
Oh. Okay, that was that. Well, first off, hit second clear. Okay, let's clear this out. Okay, then press stat. Do you have data in the list? Okay, and then arrow right to calculate. And then hit enter. Do you have it in list 1?
Yeah.
Okay, that's how I got it, and then I arrow down. Keep going. Okay, you just missed that step. I arrowed down to see the 5-number summary. Okay? Alright, is there anybody else have a question? I just figured we do have a lot of work to do in this class, so we can spend some time. Yeah.
Are downloaded the show yet? Are we able to like type on here?
Only, you can only, okay,
Or do we have to have an iPad?